We have left at the part where I was about to define the dynamic monopsony. Mm. I should mention that actually, um, in previous parts in background, I have already made the basic definition, but let me repeat it as the main part of the course now. Dynamic monopsony is created when leaving a job is costly for a worker, even if it's possible to find a better job, which means basically you are working at a job. You know there are different jobs available, which sometimes look other workers, which have a significant chance of taking you. Um, well, even the chance of them taking you is 100% basically. Uh, Changing jobs might be costly. Well, uh, looking for jobs will be even more costly, and that cost itself gives the company uh, um, um, monopsony power over its workers. And the less resources a worker has, the more costly will be, well, the time you stay unemployed for 1 day, 2 days, three, 1 week, 1 month while you are looking for a new job. Uh, and I mean, here the real money amount is not that much important. I mean, the cost will be the cost will be higher for the people, um, even if the monetary amount is the same. The cost will be higher for the people who uh, well don't have sufficient wealth to basically pay that cost in case their income stream is cut basically through the while quitting job and looking for a new job, or even if they are still in the job, looking for a job might be difficult for them if their job is requiring already a lot of effort but pay little amount. So it might be difficult for them to use the remaining time and resources for looking for a new job. Um, so this is dynamic monopsony basically, and we will see the details of it, as I said, in the job search chapters, which is, in my opinion, most interesting chapter, where we will basically um, go beyond the neoclassical model, basically the main neoclassical labor market model. It's still neoclassical, by the way, the job search models, but the main labor market model we will be left kind of behind. Um, so let's start looking through the questions. How do monopsonic employers determine the optimum level of employment in case of a monopsonic labor market? They basically set the optimum level of employment at the level where marginal cost of adding another labor is equal to the marginal revenue this additional worker will bring, just like the normal case. The difference is the marginal cost is not anymore equal to wage. It is the cost of increasing wage of the previously the remaining workforce is also included to the marginal cost of adding another worker, unless you have a minimum wage law which fixes the wage basically, or sets a lower boundary. Why is the marginal labor cost of a new worker higher than average the paid wage in a monopsonic market? I said it's because, well, it's not like you hire workers one by one and pay them. It's rather like you decide how many workers you will hire, and you cannot pay them different level of wages, which basically which basically means that when you hire the next worker, basically you one more worker, you need to raise wage of all previously all workers which you already were considering to hire. So the raise they get is added to the cost of hiring one more worker. Assume the graph on the right represents the cost and revenue brought by each new company worker by each new worker to a company, at which point there is no exploitation according to neoclassical definition C, because here the wage level, which is represented by supply curve for different labor quantities, is equal to the marginal revenue product brought by the last worker. Assume people living in the state of Carpathian employers in that borough have a monopsonic power. How can TRNC decrease that monopsonic power? Monopsonic power was basically um, uh, based on the cost of leaving a job and finding a new job. So certainly decreasing job search costs, making looking for a job easier for the people, will make it easier. Maybe decrease the monopsonic power. Maybe also making the jobs relatively more standards and making a person working in one company to adapt to the other company in a faster way might also decrease the monopsonic power of them. Employers, because in that case, I mean, the investments you have made in that company won't be that critical. They will be also valid in the other company. What is natural experiment? Natural experiment is the experiment when experimental conditions are set by the nature itself, in which case, actually, the society itself might also set those standards. What are the basic standards of an experiment? You need to keep all variables constant except one variable you are testing, and that variable is the one for which the effect of which you are testing, basically. Okay, assume the price of steel per ton is $100 per ton for a steel factory. When factory sells 100 tons per steel per day, also assume each additional 100 tons will reduce the price by $2.5. Construct a table that shows marginal value, total value, average value for 100 ton between 100 for every 100 ton between 100 ton and 4,000 ton. The good thing the fact that you can get many values for many variables pretty fast. That's why I keep the number large here. Let's do that. So the quantity is the one thing, and then the price, which is equal to average revenue, and then you have you have total revenue and you have marginal revenue. The quantity was, if I'm not mistaken, increasing by hundreds in increments, and the first steel was basically $100. So this plus one, not 100. Price starts with 100 and then it decreases by 2.5, 2.5 of course. This case, and in some computers it can be 2.5, in some of them 2.5. Total revenue is you just multiply quantity with the price. Marginal revenue is for the first line equal to total revenue. For the second line, it is the differences between adding. Of course, this is marginal revenue for the 100 tons. That's 100 tons is in this case 1 unit. So you do this all the way to 40,000. 4,000, I believe. If it's 40,000, it's meaningless, since I mean already much before it. Yes, 4,000 ton. So you can see this. So that's the first question. Assume in order to produce every 100 ton, the factory employs 100 time workers. Assume wage is $1,000 per day. What will be optimum number of workers the company will employ in this case? So, case 1, the marginal cost and the average cost of workers is the same, which is 100 times 10, which is 1000, because you employ 10 workers for each of them. Okay. Total cost is, of course, well, basically you multiply these two numbers and then divide it to 100, or multiply it with this. So the optimum point is when the marginal cost and the marginal revenue are equal to each other, which happens at the point when you produce 1,900 tons. This is basically the optimum point. Okay, let's do the D parts. Well, basic question also. Assume at optimum quantity the company employs 100 and, well, let's skip this for now. Draw the graph showing marginal and average cost and marginal revenue and average revenue for perfectly competitive market case. Show the competitive market equilibrium. Okay, let's do that. Okay. Average revenue Y values are marginal. These ones. This is just average revenue. I should add more. Marginal revenue. X value same. Y values here. Oh, not here, I'm sorry. Here. Well, for the average revenues, I will make a modification. But let's continue for now. Marginal cost and average cost, which are the same in this case. Which is this. Okay. The main point is, since my 1 unit was 100, I should multiply this with 100. Of course, in this case, I should multiply this with 100. Oh, no, I'm sorry. I should equate this. Okay. So this is the graph, basically. Well, I have made a change here. Previously, I was multiplying this price with the 100 to find the total revenue. Now I divide the number I find to 100, since prices are defined per 100 ton, basically. And then basically you got a graph like this. Okay, I can basically, I will talk on this graph more in the next part. I will also make some changes on the graph. See you in the next part.